What if the solution to Earth's energy crisis isn't on Earth at all? What if clean, uninterrupted electricity could come not from coal, wind, or ground-based solar panels, but from space? Scientists and engineers across the world are working on a technology that sounds like science fiction, but is very real. The solar satellite power system, also known as space-based solar power. In this video, we'll break down what it is, how it works, why governments are investing billions, and whether it could actually power our future. So what is a solar satellite power system? A solar satellite power system is a technology that collects solar energy in space and transmits it wirelessly to Earth. Instead of placing solar panels on rooftops or land, massive panels are mounted on satellites orbiting the planet. These satellites capture sunlight continuously, convert it into electromagnetic energy, and beam it safely back to Earth as electricity. The key idea is simple. Space receives constant, uninterrupted sunlight, unlike Earth. No night, no clouds, no seasons. Now the question is, why collect solar power in space? On Earth, solar power has a major weakness: inconsistency. Solar panels stop working at night, during storms, in winter months, in dusty or polluted environments. In space, none of these problems exist. Sunlight in orbit is stronger, continuous, and up to 8 times more efficient than on Earth. A single large solar satellite could theoretically generate gigawatts of power, enough to supply an entire city. Let's see how the system works. Let's break the process into 4 simple steps. Step 1: solar collection. Large solar arrays mounted on satellites capture sunlight in orbit, usually in geostationary orbit, where the satellite stays fixed over one point on Earth. Step 2: energy conversion. The collected solar energy is converted into microwaves, most common and safest option, or laser energy, more precise, still experimental. Step 3: wireless transmission. The energy is transmitted as a low-intensity beam toward Earth. Despite popular fear, it is not a weapon. It does not burn objects. If the beam deviates, it spreads and loses power. The intensity is often compared to standing in sunlight. Step 4: ground reception. On Earth, large receiving antennas, called capture the energy. They convert the signal back into electricity, feed it directly into the power grid. Another thing which pops up in the mind is that, is it safe? Safety is one of the most researched aspects of this technology. Studies show the power beams are safe for humans, safe for aircraft, safe for wildlife, and automatically shut down if misaligned. This is not science fiction weaponry, it is controlled energy transmission. Now, who is actually building this? This is not theoretical research anymore. Major players include Japan, JAXA, pioneer of space solar research. China, planning orbital test stations. United States, NASA and military. United Kingdom Space Energy Initiative, which successfully tested space-to-Earth power transmission. In 2023, scientists proved wireless power transmission from space actually works. The remaining challenges are cost and scale, not science. So when will we see it used? Realistic timelines suggest 2030s military bases, remote locations. 2040s supplemental grid power. 2050 commercial energy systems. Space solar power won't replace all energy sources, but it could become a stable backbone of global electricity. So why this matters for the future? This technology could power cities, greenhouses, desalination plants, remote agriculture, disaster-hit regions. Constant clean energy could change food security, climate resilience, global energy inequality. And that's why countries aren't asking if this will happen, but who controls it first. The future of energy may not be built on land, but above it. Solar satellite power systems represent one of humanity's most ambitious attempts to solve Earth's energy crisis. And the race to space-based power has already begun. If you like latest tech updates, like and subscribe. It is the best way to support us in continuing to do it.